So we said we're setting the fuel mass to 10,000 kilograms. The cloud height can stay the same. We're putting the average pipe diameter as 0.058 meters, which is 2 inches. You can leave this. This will be automatically calculated from the values here. We're going to set the VBR to 0.035. The default number is 0.05. It's a little on the high side. And we'll set this to 0.2, the confinement ratio. The confinement ratio basically is if you have a gas cloud that is just open in mid-air, not sitting on the ground, then the confinement ratio is 0. But a gas cloud will be at least on the ground. That's why you're interested in it. So the minimum value is 1/6 for this parameter. And 1/6, that's 0.166. And now if you have more, if you're like within a building or a structure, it can go all the way up to 1. So that's the parameters here. That's it. That's all you need to actually run the simulation. I'm going to close this, and then we're going to put the gas cloud in here. I'm going to put a gas cloud in here. That's the extent of the gas cloud. It's important to know the volume of the gas cloud, the mass of the gas cloud, how much gas is in there. There's some calculations to go along with that. But apart from that, you're ready to go, and you just press Perform Analysis. And it starts calculating. It's calculated now the pressure ratio in our region to be about 1.42. It'll start calculating now the CFD. It'll take some time. I will pause this video and we will return to part 2c to process the data. So you can see that the calculation has started. We'll come back with the post-processing of the data. When the calculation is finished, here it will automatically open ParaView, which is the viewer. So you'll see when the calculation is done, the viewer automatically opens, and that's what we'll start off with at that stage. Okay, thank you for listening.